Hello students, hope you are all safe and healthy at home. Let's start with our new topic for chapter motion, that is uniform motion and non-uniform motion. Motion we all have studied. It is nothing but the change in position of an object with respect to time and surroundings we have studied in the previous lecture. It can be divided into two parts for according to our syllabus, that is uniform motion and non-uniform motion, right? As this name suggests, uniform means what? Uniform means constant, same, similar. Okay, so uniform motion means a motion in which something is constant, something is equal or same, right? So let's take an example to understand uniform motion, as we have taken the previous lecture also. Suppose this is a straight line where the object has to move. Object is moving from one point to another point. Suppose this is the starting point or reference point O, and this is the reaching point or final point, that is A. Okay, if the object is moving in a straight line in this direction, okay, the object first of all moves till this point, suppose P, then the object moves till this point, that is Q, then the object moves till this point, that is R, then the object moves till this point, that is S. Okay, so object is covering some distance in this case and reaching point A, suppose. Okay, in this whole journey the object is covering some distances till point P, then Q, then R, and then S, and these distances we can see over here that these are equal distances. O to P is similar to P to Q, and then it is equal to Q to R, then R to S, then S to A, we can see, right? Suppose this distance is 5 meters and this distance is also 5 meters. These are all equal distances, right? And this distance is covered in a time interval of suppose 2 seconds, and in the next 2 seconds next 5 meters is covered, and in the next 2 seconds next 5 meter distance is covered, like this. Suppose this is the case, then what happens? We can find out the speed over here, and we can say this type of motion will be what kind of motion? It will be a uniform motion, because it is covering equal distances in equal intervals of time. This kind of motion of an object will be called as uniform motion. In this case, what is the speed from O to P? From covering distance O to P, what is the speed of the object? Speed is nothing but distance upon time, that we all know. Okay, so it is 5 meter divided by 2 seconds, that means 2.5 meter per second, that is the speed. Okay, in the next case from P to Q the speed will be same, right? In the next case Q to R the speed will be same, that means the speed is constant in every case. So we can say the speed is also uniform speed in this case. In the case of uniform motion, the speed remains constant. So what can we say? The speed remains constant in the case of uniform motion, right? Now what is non-uniform motion? In other words, we can say, we can have a similar example. Suppose I will write down over here itself just to have better understanding. In the case of non-uniform motion, that means non-uniform means something is not same. So what is not same? In this case, the speed will not be same or not be constant in this case. How? If we consider that the distance covered by the object in the first case is suppose 5 meter, and in the second case was 6 meter, and in the third case it was 8 meters, and then it was suppose 4 meters, for example. Okay, and the time interval may be same or may not be same. Suppose we are considering over here the time interval same, in 2 seconds, in 2 seconds, in 2 seconds, or in 2 seconds. It may be same, it may not be same, it may be 3 seconds also over here. Okay, so when the unequal interval, in unequal intervals of time, if we consider, or when we consider the unequal distances, then the speed will not be same. In this case, what will be the speed? 5 by 2, that is 2.5. In this case, what will be the speed? 6 by 2, that means 3 meter per second. In this case, 8 by 2, that means 4 meter per second. In this case, 2 meter per second. So in every case, in every part of the journey from O to P, P to Q, the speed is not same, the speed is not constant, the speed is not uniform. So this kind of motion of any object is known as non-uniform motion, right? For example, we can say then when our car is moving in a traffic, then in one case, at one part of the journey, the object, that car is having a particular speed, and the other part of the journey, when the traffic is less, then that will be having more speed. So the speed is not remaining constant. In that case, we can say the car is having non-uniform motion. But if the car is moving on highway where it is having a similar speed, suppose on highway the car is moving with 100 km per hour for a particular distance, for suppose O to A, this particular distance, or suppose for O to R, a particular in a particular span of time, there may be no traffic, so the car may move with a constant speed or a constant or a say speed, okay, or a uniform speed. So in that case, we can say the car is moving in a uniform motion, right? So we talked about speed over here in the case of uniform and non-uniform motion, right? Let's talk about the type of speed also. How many type of speed we can have? In this manner, we can have two types of speed. That means uniform speed we can understand, and non-uniform non-uniform speed. Uniform speed and non-uniform speed. When we are having uniform speed, then we have a constant value of speed that we have understood, okay, and when we have non-uniform speed, then we have different values of speed in the different cases, like here we have understood, okay. So if we have different values of speed, we can find out one average speed, okay, one average speed, that means average of all the values, average of all these values we can find out, and one average speed we can find out always, right? So in this case, we can say we have two types again. One is average speed that we have to understand or we have to learn, and another kind of speed is instantaneous speed. Instantaneous speed. What does it mean? Instantaneous comes from, this word comes from the word instant. Instant means at a particular time, right? So instantaneous speed means the speed at a particular time. For example, uh, let's say we are moving in a car in a highway. Okay, we have different kinds of speed from Delhi to Jaipur. If we are traveling, then we can have different types of speed. So many ranges of speed we can consider in that case, in that journey. So what is the average speed? We can find out the average speed from different when we notice different types of speed in that case. And what is instantaneous speed? The instantaneous speed is the speed at a particular instant, whatever our speedometer is showing. Okay, suppose at 10 o'clock exactly, what was the speed of my car? Then I can notice at 10 o'clock in my watch, and the speedometer of my car is showing, if it is showing 95 kilometer per hour, then that will be instantaneous speed. So instantaneous speed is the speed which is shown by our speedometer in the car. At a particular instant it is showing. If we slow down our car, it is its needle comes down, and it is and it must be showing some 50 or 55, whatever it is, right? So this kind of speed is known as instantaneous speed, right? Now comes the formula and the unit, SI unit of the speed that we are going to use in this chapter. It is nothing but we have learned this formula in our lower classes also, that is speed is equals to distance upon time. And according to this formula, distance is measured in meters, time is measured in seconds for SI unit. So SI unit becomes meter per second, or it may be written as like this: meter ms to the power minus 1. This is very important to understand, because in whole of the chapter, or in all the chapters, you can say this denotation you may get. Okay, and this you should understand what does it mean. What is the larger unit of speed that we are using nowadays in our daily life? That is kilometer per hour. Or we can say kilometer per hour, right? This is the larger unit that we are using, and this is the SI unit. This is larger unit, larger one. Okay, now we have the formula for average speed also over here in your syllabus. How to find out average speed? We cannot find out average of many values. Like if we are having 4 values, then we can find out the average. Okay, this plus this plus this plus this divided by 4, that is a simple method. But if you are having thousands of values from Delhi to Jaipur, if we are traveling, we can change our car's speed thousands of time, okay, or hundreds of time we can change. So we cannot find out the average value of speed over there by just adding and dividing it by 1000. It is very difficult. So what is the easier method? We are using the formula, and that formula says that average speed is equals to total distance. Very simple formula: total distance divided by total time taken. Total time taken by that object to move, to travel, that distance. Total distance is suppose 300 kilometers, and total time taken is suppose 6 hours. So then the average speed will be found using this formula. Okay, next comes our topic is velocity, which is completely related with speed. Next topic is our velocity. What is velocity? It is nothing but speed of any object along with the direction specified. The speed with direction. Okay, direction word is very important over here. If we are moving from, for example, if we are moving from Delhi to Jaipur in our car, so what is the direction of movement at NH8 from towards Jaipur? So what is direction? Towards Jaipur. This direction should be specified when we are talking about velocity of the object. If we are saying that our car is moving with the speed of 80 km per hour, 80 km speed is 80 km per hour, then it means it is speed. If we are saying that our car is moving with the speed of 80 km per hour towards Jaipur, then it means that it is velocity, right? So this is the difference is not very large difference but very big difference, but it is very important difference, right? So similar to the speed types, we can have velocity types. Velocity is also of 3 to 4 types. That is, one is uniform velocity. In uniform velocity, another is non-uniform velocity. In the case of non-uniform velocity, again we are having average velocity and instantaneous velocity, right? Similar to the speed types, we are having these 4 types, right? In a similar manner, we can understand this. Uniform velocity means, what is uniform? The velocity of an object will be uniform, but we have to specify, or we have to understand that very clearly, that in this case the object is having a constant speed as well as a constant direction or a same direction, because velocity is speed with direction. Speed with direction. If the speed is also same and direction is also same, then we can say that the velocity is same or uniform, right? So both should be same in this case. In this case, your speed should also be same plus direction will also be same. Then we can say the object is having the uniform velocity, right? In this case, now the speed may not be same and direction may not be same, or both may not be same. That means for the case of non-uniform motion, for the case of non-uniform velocity, we can say that if the object is moving with the particular speed, a constant speed, but it is changing the direction, then it is non-uniform speed. So what can be the cases for this one? For non-uniform speed, we can say that one is when our speed is constant but direction changes. Second is when our speed is not constant but direction is same or constant. Okay, in this case the speed is constant, in this case the direction is constant, but one of the thing is not constant. That means it is non-uniform velocity. And in other case also, in the third case, if both are not constant, both speed and direction are not same, then in that case also we will say the object is having non-uniform velocity. So non-uniform velocity, if we are specifying, then we should definitely specify that whether the speed is constant, whether the speed is changing, or the direction is changing, or both are changing. Then we should know why it is non-uniform velocity. So this part is very important to understand and to remember, right? If these three things may happen, any of these three things are happening, that means the object is having non-uniform velocity. And if the object is having non-uniform velocity, then it can have, we can find out average velocity, and we can find out the instantaneous velocity also in the similar manner as we have done in the case of speed. Average speed is total distance traveled divided by total time taken, right? In the same manner we can have this formula. So first of all, see the formula for velocity. Velocity is nothing but displacement divided by time. It is not distance divided by time, it is displacement divided by time. Why? Because corresponding to distance, displacement is a physical quantity which is having direction, or which is a vector quantity that we have understood in the previous lecture. Okay, so in the place of distance, displacement is showing the direction, it is specified with the direction. So in this case, for a case of velocity which is specified with the direction along with the speed, then the formula for velocity becomes displacement upon time. Okay, and the formula for average velocity becomes total displacement divided by total time taken. This will be the formula for average velocity, right? So let's talk about the unit. What will be the SI unit for velocity? That will be meter per second, same, because we are specifying the numerical value in speed. Okay, the direction does not have any particular value for unit, so units will be for the particular numeric value of any physical quantity, right? So SI unit will be meter per second, and the larger unit again will be similar, that is kilometer per hour, or we can say meter per second, like this, or we can write down in this manner also. Okay, now one more formula we can have over here for average velocity. One more formula. In what case this formula will be used? That is the case when the change in velocity is uniform. When the change in velocity is uniform. Change in velocity means, in this case, the of non-uniform velocity, if we are saying it is non-uniform velocity, that means the velocity must be changing all the time, right? From P to Q, Q to R, R to S. For every period of time, or for every type of distance, the velocity is not same. If it is not same, that means it is changing. And if it is changing at a particular uniform rate, right, it is changing uniformly, then we can use the formula for average velocity as initial velocity plus final velocity divided by 2. That means mean of initial velocity and final velocity. Let's understand this more deeply, as the concept is new. We are taking another example, a similar example. If we are having this part of distances A to B, B to C, D and E. If from A to B the object is moving, if from B to C the object is moving, C to D and then D to E, right? The direction is same, I'm considering. In this case the direction is same, but the speed, I'm considering the speed is changing. That means this is second case. Speed is not constant but the direction is same. Because of this we are getting non-uniform velocity. Okay, so non-uniform velocity we are having, and we are having the change. If in the first case our velocity is 2 meter per second, and in the second case our velocity becomes 4 meter per second, and in the third case it becomes 6 meter per second, in the fourth case it becomes 8 meter per second. Whatever is changing, we can consider anything, whether the time is changing or the distance is changing, but the velocity is changing because of those factors. And it is changing by what factor? Every time it is changing by factor of 2. You can see 2 plus 2 4 plus 2 6 plus 2 8, like this. If the velocity is changing and it is changing at a uniform rate, it is changing at a uniform rate. What is the uniform rate? Uniform rate means it is changing by increase of 2 always. कितना increase हो रहा है? It is increasing by 2, right? So every time the velocity is changing by the same factor, that is 2 meter per second. This kind of change is known as change at a uniform rate. There is a change in velocity at uniform rate, or we can say the velocity is changing uniformly, right? In that case we can use the formula for average velocity to be this one, that is initial velocity plus final velocity divided by 2. What is initial velocity? That is 2 meter per second. What is the final velocity? That is 8 meter per second. 8 plus 2 divided by 2, that we will be getting. 8 plus 2 is 10 and 10 divided by 2 is 5. So your average velocity for this traveling is 5 meter per second. Okay, the answer will remain same. If we are using this formula or we are using this formula, we can have the same answer, right? So let's see some of the examples given in your NCERT book. This is your NCERT book, page number 101. We can have this example. 8.1, we should understand this. An object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? We know what is the formula for average speed. That is total distance divided by total time. So what will be the total distance? 16 meter and then another 16 meter. That means 16 plus 16 is 32, right? So we can solve it like this. So total distance in this case will be 16 plus 16, that is 32. This is very simple. And then total time, what is the total time? Total time will be 4 seconds plus 2 seconds. 4 plus 2 is 6. So what will be the average speed? That according to formula, that is total distance divided by total time. That will be 32 divided by 6, and that will be approximately 5.3 meter per second. This is how we have to find. Very, very simple. According to the formula we can write down. But one thing I want to specify over here, that whatever numerical we are adopting or we are attempting, we should write first of all the given things, and then we should write down the formula, and then we should write down what? we should put the values according to given things and then solve and find out the answer. These 3 steps must be followed, right? That is given in your solution also. You can see over here, total distance traveled by the object 16 plus 16. Okay, that is the given thing. And total time taken we have written over here, and then we have written the formula and then put the values and then find out the answer, right? This must be the method for every type of the numerical that we should follow, right? Let's see some other numerical or questions related to this topic we can discuss. Example 8.2. The odometer of a car reads 2000 km at the start of a trip and 2400 km at the end of the trip. If the trip took 8 hours, calculate the average speed of the car in km per hour and in meter per second. So how should we do this? Let's take another page. Odometer of a car is telling you the distance traveled by the car. So how much is the distance? 2000 km at the beginning of the trip when the car started, it was showing, and when the car stopped at the end of the trip, it was showing 2400 kilometers. So what will be the total distance traveled for that trip? That will be 2000, from 2000 to 2400. That means 2400 minus 2000 should be, that means it should have traveled 400 kilometers. So total distance we will get 400 kilometers from here. And if the trip took 8 hours in total, so total time they have given, so in kilometer per hour we can find out the value. Okay, so total, let's see, total distance will be equal to 2400 minus 2000, that is equals to 400 kilometers. Okay, and the total time that we want for finding the average speed, that will be 8 hours. Okay, so average speed in kilometer per hour, we can say it is 400 divided by 8. Okay, so that will be 50 kilometer per hour. In kilometer per hour we have found. For meter per second, what we should do? We can convert 50 kilometer per hour into meter per second over here. How to convert now? Now 1 kilo, we know that 1 kilometer is equals to 1000 meters and 1 hour is equals to 3600 seconds, right? So we can use this basic concept for 50 kilometer per hour. 50 kilometer per hour means divide by hour, so it will be equal to 50 multiplied by 1000 and divide by, for hours it will be 3600, right? So how much it will be? Zeros are cancelled. Okay, from 2 you can write this 5 and then this is 18. So if we multiply the figure given by 5 by 18, we can say then it will be converted into meter per second, simply meter per second, right? So this is the way. You must remember, if you multiply the given thing in kilometer per hour by 5 by 18, then we can have directly converted value into meter per second. So this will be equal to 13.9 meter per second. Okay, now let's see these questions. based on the topic that you can do in your notebook later on. Distinguish between speed and velocity. What are the differences between speed and velocity that we can write down? First of all, we know the definition for speed, right? Speed is nothing but distance traveled by an object per unit time. Okay, and what is velocity? It is distance traveled by an object in a particular time in a particular direction also. That is the difference, one basic difference. Another difference that we know is what? That is speed is a scalar quantity. Speed is a scalar quantity and velocity is a vector quantity. Why? Because it is having magnitude as well as direction. It is having only magnitude value. Okay. Speed tells us how fast an object is moving. How fast an object is moving by the value we can know, and velocity will tell you how fast and in what direction it is moving. Okay. Average speed, if we talk about average speed of any object cannot be 0. In this case, average velocity can be 0. How? Because velocity is displacement divided by time, and if displacement can be 0, we have understood in the difference between distance and displacement. If you remember, if displacement can be 0, then velocity can also be 0 in that case, right? Similar to the distance and displacement differences, we can write down one more difference, which is that the speed is always positive. It is always having positive value. But velocity, because it is direction dependent and dependent upon displacement, so it can be positive, it can be negative, and it can be having 0 value, right? Second question is, under what conditions is the magnitude of average velocity of an object equal to its average speed? Under what condition it can be equal? The average velocity and average speed. See, what is the formula for average velocity? We have done average speed. Suppose we are writing over here speed and average velocity. It is total displacement divided by total time, and it is total distance divided by total time. Okay, under what conditions these two can be same or equal, they are asking in the question. So what is the difference between these two? There is a difference of distance and displacement. If distance and displacement are equal, then the average speed and average velocity must be equal. And when the distance and displacement will be equal? When the object is traveling in a straight line, then we can say that distance and displacement can be equal and speed and velocity can be equal in that case, right? For question number 3, what does the odometer of an automobile measure? It measures nothing but distance. We have done in that example. Okay. What does the path of an object look like when it is in uniform motion? When the object is in uniform motion, the path of an object can be a straight line, right? Or it can be a curved line also. For uniform motion, we cannot describe the direction. Okay, for uniform motion, we are only considering the speed, right? So the path can be curved also, the path can be a straight line path also. For if it was uniform velocity, then it must be a straight line only. Okay, now let's see another last question, which is a numerical. During an experiment, a signal from the spaceship reached the ground station in 5 minutes. Okay, the signal is reaching the station in 5 minutes. Okay, so what is the time? That is 5 minutes to travel that distance from spaceship to the station. Okay, so we can write down the distance. Okay, sorry, time is given, so time is equals to 5 minutes. Okay, what was the distance of the spaceship from the ground station? Okay, the signal travels at the speed of the light, that is 3 multiplied by 10 to the power 8 meter per second. That means speed is given over here, that is 3 multiplied by 10 raised to power 8 meter per second. If it is meter per second, what I am doing, you can see I am writing the given things first of all. Given thing is time, this given thing is speed, and we have to find out the distance to be found. Okay, so what is the formula? Speed is equals to distance divided by time, right? So from this formula we can find out distance equals to speed multiplied by time. What is the speed given in? It is given in meter per second, so we have to make the units same. For 5 minutes we have to convert into seconds. 5 multiplied by 60, that means 300 seconds. Okay, so it will be 3 multiplied by 10 raised to power 8 multiplied by time is 300. So what it will be, 2 zeros will be added. Okay, and 3 3s are 9 multiplied by 10 raised to power 10 meters. So this will be your distance. Like this we have to calculate. Okay, hope you understood this complete topic along with the questions we have discussed, and one question is remaining, I think, that over here. This is also important question. You can see over here example. Please understand this. Usha swims in 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight path. So she is a swimmer and she swims 90 meter in a long pool. So what is a pool considered? That is, we can see this is the pool. Okay, the pool is like this. Suppose this is the pool and it is 90 meters long. So swimmer is swimming from this direction to this direction. She covers 180 meter in 1 minute. 180 meter means 90, she goes over here and then coming back. That means total 180 meter when she is coming back, and the time taken is 1 minute. It can be written as 60 seconds, right? So, and back along the same straight path. Find the average speed and average velocity of Usha. Now they are asking average speed also and average velocity. This is the point to understand. Okay, average speed. What is the average speed formula? Average speed is equals to total distance divided by total time. Okay, total distance she has covered 180 meter, 180. Okay, and total time she is taking as 60 seconds, right? So it will be 3 meter per second. That is your average speed of Usha. And what is average velocity? Average velocity is total displacement divided by total time. What is the displacement over here? When the person is going from this point to this point and then again coming back. So displacement is the shortest distance between initial and final position. What is initial position? This. Since she is going over here and then coming back, what is the final position? This is only the final position. If initial and final positions are same, then the displacement becomes 0 in that case. So displacement in this case is 0 and distance in this case is 180. There is a lot of difference. So in this case, this total displacement is 0 divided by total time, that is 60. It becomes 0 meter per second, right? So this is important to understand. This is the difference between speed and velocity whenever we calculate, right? Hope you understood all these questions and topic. The next topic will be taking complete as in the next lecture. Thank you.